So, okay. Law of sines. Now, the area of a triangle is not the law of sines. Totally different thing, but it's something we like to bring in on this particular section. The area of a triangle is still going to be 1/2 the product of the lengths of our two sides. So when we do half base times height before, it's kind of running that same way, except we're also going to include the sine of the included angle. For instance, which means if I start to look at these area formulas, if I have sides B and C, notice what angle gets trapped when they come together. It's A, so I'm going to use the sine of that angle. If I have sides A and C, and I look, what angle do they produce? Well, they produce this one. They produce B. So that's what we're talking about when we talk about an included angle. Two sides, angle in the middle. I can use that to be able to figure out the area of that triangle. So when I get down like to number 1, I notice the two sides they give me form, when they come together, the included angle, the angle in the middle. So all I have to do then is do 1/2 the product of the two sides that I have times the sine of that angle. But again, I want to make sure when I'm doing this, when I go to mode, oh, see, I'd have gotten in trouble. Make sure I'm in degree mode, and I'll warn you in advance, my regular Algebra 2 is doing stuff with radians right now, so there's going to be all this flipping and wars back and forth with who's getting what. So always check the mode if you're using one of the calculators in here. So mode, make sure you're in degree, because otherwise, yeah, it's going to get kind of ugly. I also like to use the decimal form of 1/2 instead, because sometimes we forget to put the 1/2 in parentheses and we get all sorts of weird, funky answers otherwise. And here's where we'll find out if some of you are still in radian mode. You should be getting about 71.5 as your area. If you're getting some other strange number, check the mode again, because you're probably in radians unless you pressed a number in incorrectly somewhere. And when we're doing these, again, as long as I have the two sides with their included angle, and it has to be the included one, I can just keep using this formula. So it's nothing that's really that tough to do. It's just remembering that it's sine of the angle. Otherwise, it's a lot like the regular formula is for finding the area of a triangle. And I just go ahead and write that to the nearest tenth, and I have my area. Now, you may not always be given a picture. Pictures are nice. If you're not given a picture, you can always draw one. So it's not like you couldn't do that. But when you stop to think about it, if you do get yourself into a problem like, let's say, number 4, I still can realize that I'm going to be okay, because the included angle will always be a letter different from the first two. So if I have side A and side B, that's what the little letters stand for. The capital letters are always going to be my angles, so side A, side B, angle C would be trapped in there. Because whenever I'm doing one of these, it kind of lets us introduce something. So I'm going to go ahead and draw a picture here. You can draw any kind of triangle you want. And I'll label my angles. Whenever you're dealing with a triangle's angle and its corresponding side will always be opposite of each other. So sometime if you're just given letters and you're trying to figure out, okay, what do I have and what do I need, this is a basic setup that you can work with that every single time. So here I notice, okay, so I have B, I know what angle C is, and I can see that it's included. I don't have to draw the picture, but I could. Otherwise, I'd just go ahead, plug this in, and then just let the calculator do all the heavy lifting. And since we're going to the nearest tenth, looks like we're getting a whole number angle this time. Well, not an angle, goofy man. I'm looking fine in the area. I'm getting ahead of myself. But that's how we're going to do this. Now again, be cautious. Sometimes you'll be given more information than you bargained for. Like number 5. Which one of those 3 angles am I going to be using? 36. I'm going to be using C because the 8 and the 14 create angle C. So it would be half of 8 times 14 times the sine of 36. End up with an area of 32.9, because I always got to make sure it's that included angle, okay? That usually isn't too bad when it comes to trying to work some of these things out. It gets to be some of the other a little more in-depth issues that can be a little more troublesome. So let's actually introduce our first law. The law of sines to solve triangles. You'll notice this law of sines is on our help sheet that you got yesterday to be able to assist you a little bit if you tend to forget, how to work with this. If you ever have 2 angles and one of the sides opposite of the angles. So here's some like examples of sides that you could have that would work well with this. So like if you had side A, side B, angle A, you have to have one corresponding side and angle for this to work. Or if you had side B, side C, angle C, again, you've got a corresponding side and angle that you can work with. That's when the law of sines comes in handy and lets us work with that. But then under interesting info, sometimes, depending on the measurements of things, you may start to do a measurement, you're like, wait a minute, I'm getting an error message. Wait a minute, that doesn't make sense. You can get some special cases that arise occasionally, and we'll talk about that when we get into some of them here a little bit later. But that's something that you got to keep in the back of your mind when you're doing these, if you get an error sometime. So okay, we're going to round side lengths to the nearest tenth and angle measures to the nearest degree. Find side CB. What I normally do, again, everybody's different, I like to actually label my sides with those lowercase letters when I have the capitals, because then it lets me visually see what I would see in here. Like, what do I see here right now? Well, I find it says side CB. Okay, to me that means side find A. Side find A, wow. Find side A. So I look and I say, do I have a corresponding angle and side somewhere? Yes, I have angle C and I have side C. So that is going to be my first fraction in this proportion. I'm always looking for that first. Then I look and I'm like, okay, I'm looking for CB. I'm going to call it A. You can call it CB if you want to. But I also have its corresponding angle, the sine of 15. Once I set up that proportion, and it's never going to be all 3 of these, it just means they're interchangeable, I'm going to go ahead and solve for what I have left. So what I normally will do here, and I'll let you see it worked fully out this first time, is going to be I cross multiply and then I just solve for A, which in this case would be dividing by the sine of 72. And then I just crank that into the calculator. So I've got 375 sine of 15, and I got to remember to close the parentheses or my answer will be kind of curious. Divided by the sine of 72. So CB is 102.1, and I've got what they asked me for. But basically the rule you're going to be working with on these is when you're trying to find one of the sides, basically it's going to be cross multiply the side that doesn't have the sign in it, and then we're going to divide by this one. So if you're looking for a way to do a shortcut, that might be a way that would work out for you. So I take a peek at this next one and I go, okay, what have I got here? Well, I know this is going to be side B, this is going to be side A, this is going to be C. So I go looking for my one necessity. I need a corresponding side and angle. Well, I notice I have a problem. I have angle B, but I don't have side B. I have angle A, but I don't have side A. I have side C, but I don't have angle C. Oh. What might I be able to do to help myself get one of those bits of info and actually be able to use the law of sines out? Right. I can figure out angle C, because I know there's 180 degrees in a triangle, by minusing the 12 and the 18. That will give me angle C, which in this case would be 150 degrees. So now I have that to use as my initial fraction. Sine of C over side C is going to equal, and if I'm looking for side AC, that's my version of B here. And its corresponding angle, its angle opposite, will be the sine of 12. So whenever I'm calculating these, if I want to save myself one step, if I like seeing this because I like seeing step by step, that's fine. If you look for the diagonal that doesn't have your variable term, you multiply those, and then you just divide by the sign term that's with your variable. And then let the calculator go to work. So side AC, or if you called it side B, I wouldn't complain. It's 21.2. And you're like, okay, this isn't too bad so far. A little bit of info. All right, find the angle B. What's my first fraction going to look like? All right, sine of 121, the sine of A over side A. There's my corresponding side and angle. And if I'm looking for angle B, I know the side, but I don't know the angle. Now here's where things change just a little bit. Because I look at this and I go, okay, I'm just going to keep doing this like I've been doing it. There's the one that doesn't have the B in it, so 119 sine of 121. I'm going to divide by 212, and that's going to get me the sine of B. So I punch it in. I start typing this in, thinking I'm all that. I got this down. And then I hit enter, and I go, wait a minute. Angle B is 0.48. That seems too small. That doesn't make sense. And then I think about it for a minute. I'm like, oh yeah, it's an angle. To get the angle measure, I need the inverse of this. So I'm going to do second sine and use that decimal. Now try not to round it. Most calculators have something where you can plug the previous answer in. On these calculators, it's second and the negative sign will get me the answer. Then I'm going to get something that looks a lot more like an angle measure. Okay? So on angles, use second and whatever trig function it is you're using, which in this case would be sine. There will be a case a little later along where cosine also might get used here, so that's why I'm writing use that trig function. But for today's problems, everything will be sine related. So let me get that out of the way. So whenever you see that B, and some of you, and we'll talk about it on number 10, Might be thinking, I think I can do this all at once. And some of you might. But just be careful is all I'm going to say. All right. First fraction to find angle C. Where is my corresponding side and angle? A. So sine of 30 over 10. I know that C is 20, but I need to know what the angle is going to be. So again, I remind myself, oh yeah, I always will put the little -1 in there just to remind myself I should see that on the calculator when I plug it in if I want to do this right. Cross multiply the ones that don't have the C and divide by that part that does. And get the calculator out of the way. So 20 times the sine of 30 divided by 10. Next, the angle 1? No. It's 90. Now, for those of you that like to be speed demons and not do multiple steps, do it all at once. You can on these. But here's the danger. I could do this right away when I type this in. The danger becomes if you forget a parenthesis, it's going to go crazy. It's sometimes seeing two signs in the same problem confuses people. But if it doesn't with you, type it all in one big swoop, get your answer out. You'll be fine. Otherwise, those are all going to run the same way. Make sure you get that corresponding side and angle. One more. Number 11. What's my first fraction going to look like? I agree that over here I will be looking at the sine of 75 over x or b or whatever you want to call it. I agree. Nice. Sine of 68 over 22 because I already have these two angles. So if I subtract them from 180, I can get my C. Okay, so same thing here. The one that doesn't have B will cross multiply first and divide by the one that does. And again, I'm back to a side. No second on sides. Well, because you'll get an answer that looks kind of goofy. So I'm hoping that that would keep some of you from writing that down as an answer. So 22.9 sounds good for B. Okay? That, in a basic way, is typically what you're going to get with these. Now, I talked about how a special case can pop up every once in a while. So let's tackle that. So I come over here and I go, okay, this is where life gets a little more interesting. So here I want to solve ABC. Seems fairly normal. I have a corresponding side and angle. And when it says solve triangle, it means I want to know all the sides and all the angles. I got to find them all. So if I don't think about it at all and I just start, I'd be like, okay, I'm going to go ahead and I'm going to do the sine of 48 over 11. And I'm going to do the sine of B over 16. So I get my calculator out. And I start to do my thing here. So I'd have 16 times the sine of 48 divided by 11. And then I would do my second sine, and the answer, what? I'd put everything in the right way. What's going on? This is your blinking lights to say, uh-oh, problem, problem, problem. Now I need to go back for a minute and take note of some things that are on that last page for a second. Or if you have your help sheet from yesterday, it's on your help sheet too. So I come back over here and I'm like, okay, suppose you're given A, B, and A for a triangle. Hey, I was. If A is acute, yes, it's less than 90, so it's acute. I have to run through these options. So I start to look, and I'm going to do it on a note card so I don't have to flip back and forth on you guys constantly here. So we had angle A was 48, side A was 11, side B was 16. Okay, is A greater than B? No. Then I start looking at the other ones. Is A, so this is my first situation, is A less than 16 times the sine of 48? Well, let's find out. I'm being told it may be. So is 11 less than 11.9? Yes. There's no solution. This particular triangle, with the way they have these things set up, with these measurements, could not exist. So if you're ever working through one of these and you get an error message going on with something, that could be something that you might want to pay attention to. Now, here's the other part that gets interesting. And this one's actually explained right below here. Same type of situation. So I start to work through, except this time I'm getting values. I'm getting answers. But the difference is going to be, okay, use my law of sines. Okay, so I go ahead. I've got it set up here. So I'd have 8 times the sine of 34 over 6 is going to get me this angle B. Now you'd think the way I was talking I'm going to get an error message, but I'm not, which can make life a little more complicated. So I take my inverse and I get an approximately a 48-degree angle, and you're like, okay, so what's going on here? Because I've got that, I can find the other value, because if I know that B is 48, I could figure out C. C would just be 180 minus the sum of those. Oops, 34. So C would be 98, and I could go ahead and figure out what side C was. So what's the deal here? Well, here's my problem this time. Because now, with my B, I found out it's acute. It's going to have a 48-degree angle. I get my C. I do my business. But now, because of, we'll flip back one more time here. Because of this, and like we did before, let me get you the information here. A is 34, angle A. A is 6, B is 8. In this case, B is greater than A, that's true. And then is B times the sine of A is 8 times the sine of 34. Going to keep going on this for me, and it is. This whole thing's true. Tells me I'm going to end up with 2 solutions. So here's how this works. And no, these do not happen often, so do not panic. So then, once I find B, which I just did, we're also going to need to figure out an obtuse angle whose sine is the same. And all you're going to do is subtract the angle that we found for B from 180. So in this case, my second triangle that have the same measurements, my B value would be 132, and then I'd use the rest of this to find my C. 168 from 180 would be 12, and then I could find side C. It's really, really strange, and this does not happen very often. But it just means occasionally you're going to want to take a peek at that to make sure. Most of the time when it says solve the entire triangle, this is going to be the one that shows up more often. But occasionally I want to check to just see how that works. A little tricky. Little tricky, little tricky. But I'm going to get you back into some regulars here, because that's one of those very rare cases, but we just kind of put it out there just in case. So now we get to find some normal ones. Find the missing angles and the missing sides for each triangle. So in other words, whatever I don't give you, find it. Round everything to the nearest tenth. So I look and I say, okay, they gave me an angle A, angle B, side A. Easiest thing in the world to find here, missing angle. What's my missing angle going to equal? I heard it. 100. So I just subtract those from 180. I also know now that I have my corresponding side and angle. So the side of 23 over 12. And at this point, I can do either one of these. If I want to do B next, that's fine. I'll just do the sine of 57 over B. And I'm going to calculate that in a minute here. If I wanted to do side C next, that would have been okay too. I'd have used the same corresponding side and angle, except I'd have used the sine of 100 over C, because I'm going to end up doing both of them anyway. So when I go ahead and do my cross multiplying and dividing, and I usually like to show this step. I don't care if it's this one or this one, but I want to see something when you're doing these on where these answers are coming from, because then if something's going haywire, at least I can get an idea of what you're thinking. If all of a sudden I'm just seeing angle measures and sides everywhere, I'm going to be like, I'm not too sure about this. So I'll get those punched in like we have been. Get my sides in, and I'm ready and raring to go. So again, no big worries for the most part on these. But again, find everything that's missing. We found the angle, found the two sides. Now I got 3 angles, 3 sides. I'm good. I want to throw one more off of this section, and then I want to hit story problems. I'm going to flip over here. I do not want to do overkill. So I'm going to drop down to 17. Again, I notice there's my corresponding side and angle. So I'll use that. And again, when I'm here, I can go either route. Well, here, I'm going to go with A, I guess, next, because I don't have C yet. So I guess that does restrict me a little bit. And again, I always like to put that -1 in there just to remind me, oh yeah, I'm looking for the angle here. So let's see. That's going to equal 20 times the sine of 34 divided by what's ever with my sine of A. And again, it's not the sine of 25 I'm dividing by, it's just the 25. Whenever I'm looking for an angle, I'm never going to be dividing something by sine. And again, you can get brave and try and do it in one big swoop, or you can just type in what's on the right side of the equation first, and then use your inverse to get the actual angle measure. Now typically, and I know everything else has been going to tenths, typically with the angles we're going to go to wholes. But if you would have written down here 26.6, I wouldn't mark it wrong. But it also would start changing some of the other values that you get. So for the most part, our angles are going to be in whole measures, our sides are going to be in tenths. That's the way the book tends to run too. Then I want to be consistent with that. So you're like, okay, so now I got my A's, I got both B's, I need the C's though. So now what? Right, I need to find out angle C by subtracting these two from 180, which gets me a C degree value of 119. Then again, I just use Normally, I'll use the corresponding side and angle that I had in the original problem, because then there's less likelihood that I've done rounding and things start changing, and every time you get into something that has a tenth or something like that that you've rounded, it's just going to make things get a little worse as you go. So to find C, I'm going to cross multiply, divide, and when I punch that in, at least if I have calculated correctly, I believe C is going to be 39.1, which would be sensible since C is the largest angle. Side C should be the largest side. Largest angle will always have the largest side. Smallest angle will always have the smallest side. Not necessarily proportional, but that in general will be the case. So the only difference with these in a story problem is, well, instead of a regular triangle, we get some more pictures, or we get to draw something. So let's see here. Surveyor wants to find the width of a narrow, deep gorge from a point on the edge. To do this, the surveyor takes measurements as shown in the figure. How wide is the gorge? Okay, how wide is the gorge? Right there. So I start to look, and I'm like, okay, what do I have that corresponds? Well, x corresponds with this 10-degree angle. So I know the sine of 10 is going with x. Here's the question, though. What else do I have that corresponds? Right, because if I add these up and subtract from 180, this guy is 65 degrees, and then I have the corresponding angle and side. So the sine of 65 over 50. And then again, it just becomes cross multiply and divide. And I believe the gorge is going to be approximately 9.6 feet in width. So again, same thing as the triangles, it's just figuring out the information from the pictures. I saved this one for last because, well, sometimes we can get more information than we bargained for. We're trying to figure out the width of this island. They give me two angles that are both up here, and the fact that it's 1,200 feet diagonally from this plane to this island. However, they didn't give me one angle that's in the triangle, at least not directly. So I start to look at this, and they're like, okay, so this little angle right here is 27, and this one's 39. Could that help me figure out what this little angle at the top of my triangle is? How can I use those two angles they gave me already? Yeah, it's going to be 12, because it's just the big piece minus this little piece gives me the other little piece. So I see right away that the sine of 12 degrees is going to correspond with W, angle to side. Like, okay, I notice they give me another side, which I figure I'm going to have to use, but I don't have the angle. And I can't just subtract from 180 because I don't know this angle either. Uh-oh. How am I ever going to figure this out? Then I have this miraculous flashback from geometry class, when we were doing all of these wonderful things with the properties of parallel lines. Because I noticed this plane is flying perpendicular to the parallel, hopefully not perpendicular, it's going to crash, to this island. And I also notice, hey, if I look at what I always had called with geometry kids the Z shape, my alternate interior angles, if this is 27, this has to be 2. Like, oh crap, we have to remember the geometry stuff. Yes, that's going to happen occasionally. And I'll admit, a lot of times it's going to be alternate interior angles. So now I'm finally ready to get something done. That's the biggest thing with these. It's not the calculating that's hard. It's when it's a story problem, figuring out, okay, where does everything go again, and how does this work? And that can be complicated. So last one here. It looks like that whole island's about 549.6. That's not very long. So your job down here at the bottom, first one for homework check 9, is the bookwork in here. We will continue with our laws tomorrow with our first look at the law of cosines, and then we'll do some more apps from there.